So yes, as we have said, today we are talking about async in Python, and I'm glad most people haven't actually used async because this talk is pitched at a more of an introductory level. Sorry? Yes, I hope that there will still be interesting things to be shared in this talk as well. Today I'll go through a bit of introduction to the high level concept of async in Python and do some short demo, talk a bit about the syntax and then some higher level issues and what I do in my work and how I use it. So starting with a very basic example. So let's say you want to cook your dinner fast and you are only one person and you can't get someone to help you cook. How would you minimize the amount of cooking time that you need? Well, if you're cooking an Asian dish, maybe you'll put your rice in the rice cooker first, and then while it's cooking, you're gonna go soak up some dried mushrooms, then you're gonna go chop up your vegetables, start a stew, and then you stir fry, and hopefully everything will kind of be ready at the same time, and you can eat your dinner happily. However, if you start your rice cooker and then you let it and you wait for it to be done before you go on to soak your mushroom, before you go on to chop your vegetables, dinner prep is going to take a lot longer than what you could have achieved. So async Python is kind of like that. Maybe there's another example that can help us think about this. So this actually comes from a PyCon talk by Miguel Greenberg. You can search for it on YouTube. So his analogy is that imagine you have chess students, they're seated around the room, everyone has a chess set in front of them, and then you have a chess teacher who's going around the room and playing a move and every few seconds. So he just takes a few seconds to analyze the situation, play a move, then he'll move on to the next person, play a move, etc. So in this case, the time it takes for the chess teacher to go through the whole room and come back to the first student, your first student has a lot more time to think about what he should move, instead of having the chess teacher play with the first student, and then 20 minutes later he moves on to the next student. We are kind of saving the time of the chess teacher, who is kind of the important person here, and the students get enough time to think about what they move at the same time. So if it helps, this analogy is kind of what's happening when you do async in Python. Your chess teacher is your program. You want it to spend its time the most efficiently possible. You don't want him to be waiting for the student to reply to you. You want him to move on as much as possible. So hopefully these two examples help you to see a bit how async is happening in Python. So the main idea is that you are not actually duplicating having multiple processors or multiple threads to do your work. You're working with one process, one thread. It's concurrent, but it's not parallel. So you're having the same thing, same process that is trying to work through your different tasks, but just in a more efficient manner. So the big idea is you're trying to minimize the waiting time, so you can suspend and resume tasks throughout your program. And this is particularly useful when you have long input-output wait, when you are waiting, for example, for a website to respond to you, or you're waiting for a user to respond to you. You don't want to be waiting there doing nothing while you're waiting for something external to respond to you. So the main point is Python async can't help you in every single situation, but there are a few situations where it's particularly helpful. So at this point, we'll do some simple demos. So this is a kind of like a beginner demo that is not super useful, but hopefully might help to show some ideas. I'll share the GitHub link later so you can play with it yourself. So on the left, you have a kind of just a simple task that's sleeping for 1 second, and then we run through it 5 times in a for loop. And on the right, you have kind of like the async equivalent, where you have something called asyncio sleep. You're also sleeping for 1 second, and then you're kind of doing the same thing. You're running it 5 times, but then we can see, we'll try to see what's happening when we run this program. So let's run the synchronous version. So now you have a task sleeping, waking up, and we run through this for 5 times, and then the total time taken is about 5 seconds, which is what we expect. But let's say we are running now the async version. You can see that task 0 to 4 start the sleeping process, but before waiting for task 0 to come back, task 1's already started sleeping, and then the total time taken is now 1 second instead of 5 seconds. So the idea is that the sleeping thing is something that's like external to your program that's taking a long time to run, and you are just saying, okay, I want this data, but I'm not going to wait for it to come back. I'm going to start my next thing and start my next thing. So this example is not super useful because most of the time you're not trying to sleep in your programs. So maybe you have something a bit more useful. So here we're trying to get some environmental data from the government API. So let's say you want to run through several different data sets and fetch data from them. So on the left, you have your classic request. You're just doing request.get. You loop through every single type of data and you fetch your data. On the right, you kind of have an async equivalent where you kind of have the same syntax as just now, where we are trying to run a sleep task 5 times. Here we're just trying to get data for a few sets of data. So let's see what that does. Okay, so this is your classic request. You're fetching each data set kind of separately. So first you're fetching air temperature, then you get a response, then you fetch rainfall, you get a response, etc., etc. And so the total time taken is not bad. It's 3 seconds. You can afford to wait 3 seconds. But let's say you want to do it in the async manner. So what you can see what happened now is that I'm asking the fetch each type of data, and before the response comes back, we're already fetching the next data and the next data and the next data. And then at the end, everything kind of comes back after some time, and you get all your responses as well. So this takes 0.4 seconds, which, I mean, it's not 2 seconds is not going to get you anywhere in general. But imagine you're doing this like every hour, or you're trying to fetch larger data sets, then that's where this can really come in useful. Clear so far? Not lost? Okay. Okay, so so kind of what is going on in the code that we've seen so far, you see that there are 2 main keywords, await and async. So the big idea behind await is when you write await there, it means you're telling the program, okay, you can run other things here. You're kind of saying, okay, this is something that might take some time. You don't need to wait for me to come back. You can go do other stuff now. So like we can see in the asyncio.sleep case is where we say, okay, you can do something else here. So you launch the task, but you don't need to wait for it to reply. On the other hand, when you have an async keyword, you see that normally when you define a function, it's just def something, but now we have async def something. And generally, when you have async, it's in front of what we call a coroutine or async generator. So which probably doesn't mean much, but one of the PEPs in Python defines what a coroutine is. So a coroutine is when you have async def something. What it means basically is that whatever is inside, it can be suspended before reaching the end of the coroutine. So before you return the function, you can actually give control back to the main program. Even if it doesn't contain any await within this particular coroutine, you can still put async in front of it. It doesn't really matter. It doesn't do much, but you can still do an async. And interestingly, when you define something like this, normally if you don't put the async there, you return your function will return your whatever result your function is outputting. But in this case, when you have async def and you just do run task, open close bracket, you get a coroutine object. So a coroutine object is kind of special. Unlike a normal function, you need to await it, which is why here, for example, asyncio.sleep is a coroutine object. You can't just call asyncio.sleep. You always have to await it, which is probably the most basic mistake error that you make when you do asynchronous programming, and I still do it tons of times. Now I just forget to await something, and then it says, it's a coroutine. You can't just call it without await. Yeah, so there are other things that you can put async in front of, like async with or async for. And basically, that just means that within your with or for, there are things that are async. So now that we have seen this, we might think, okay, so whenever you have an async function, you need to await it. But what happens when you try to await something outside of a function? Actually, you get a syntax error. You can't just await in normal script. So if we always have to await something that's async, and await always has to come within an async function, does that mean that you cannot get a await async all the way down? So actually, no, there's a special sync function that can call async function, which is generally what we call a runner function. So to recap, in your normal sync functions, you can call other sync functions. Your async functions can also call sync functions. Async functions can call async functions, and the only sync function that can kind of call async function is your runner functions. It's a special thing that allows you to not await. So if you come back to this example, you see asyncio.run is actually wrapping around this run all, which is async, but asyncio.run isn't awaited itself. So this is kind of how you set up an async program. You always have kind of a different async dev, and at the end you have a runner function that is running overall wrapper function. So the kind of native async function library in Python is asyncio, and asyncio.run is that special function that we use to run your async functions. And you might also have noticed that other than asyncio.sleep, we've seen in this code there's a asyncio.gather. And what this basically does is saying that, okay, I want to run all these things kind of at the same time or like together. The thing is, unlike a for loop where you go through it sequentially in order, in this case, when you do asyncio.gather and then you have a list of things, the list might not be run in order. What you are sure you will get is that if you have a results, if you put results equals await this, then you know that the results will be in order, but they might not actually be run in order. So why is this useful? Well, because the whole point is multitasking, right? You want to run things at the same time. So if you're just awaiting, but you're not actually running multiple things at the same time, then you're not actually saving much time. Okay, so let's have a small pop quiz. What happens if, let me see, I'm trying to remember what I wanted to do here. Okay, so if we have on the left, you have the asyncio version where you have this run task that is sleeping for 2 seconds. On the right, you have a normal sync version where your time is sleeping 2 seconds. And then at the bottom, I'm just running the task. So is there any difference between these two mini programs? The right take longer? Anyone else? Yes. Yep. Yep. Yeah, exactly. So when you're just running one thing, it's not actually doing much, when the whole point of asyncio is useful when you're running multiple things. I mean, you can always use this function. You can use the asyncio.sleep if you like instead of time.sleep, but it doesn't actually help you much in this kind of very basic case. Okay, what happens if you do this? Syntax error, yeah, because time.sleep is not async coroutine, so you can't actually await this. What if now I wrap my time.sleep in an async coroutine and then I try to await it? Can I implement my, so like if I do asyncio.run and I gather 5 of this, would it actually be faster? No, yeah, it wouldn't actually be faster because your time.sleep doesn't know how to return the kind of control back to your main function. So it's, even though you've kind of wrapped it nicely in async, it's still going to sleep 2 seconds and you're still going to be waiting there for 2 seconds. Okay, so this few examples is kind of to show like async can't just be used everywhere you like, and you can't just kind of wrap everything you like in async and it magically makes your code faster. That it as you build stuff and it gets complicated, it's kind of important to keep in mind what you need to do in order and what you can do concurrently. So for example, if your code logic is kind of a sequential thing where you need to do A before B before C, you can't run all 3 of them together. You have to go through it in order. So let's say you want to log into a website, then get data, then something. You can't do what we did just now where you are kind of hitting hitting 5 requests at the same time. You still have to do things in order. Of course, you can implement some more complicated logic where you say that, okay, this part is going to wait for this part, etc. But in general, you need to have a good sense of what is in order and what is concurrent. And as you build more complex projects, what we've seen with this example, okay, this is a very silly example because you're just sleeping, but imagine you have a very complex library that you want to use and there's no async version, then you will be forced to use the sync version, and that will become the kind of like the bottleneck in your code. You can't force it to become async unless you go and contribute to the library yourself and make it async somehow. So if you need to use a lot of different libraries, then if they don't have async versions, it becomes a bottleneck. And what is more, in Python, we have seen like this is the basic asyncio library, but actually there are other async libraries, for example, Trio or any IO, which is kind of a wrapper around asyncio and Trio. So these different kind of async backends will implement the logic a bit differently. And if you happen to be using libraries that are relying on different async backends, then they might not work so well together. So when you choose your stack, you kind of have to keep in mind, okay, this and this, they don't work together, so I might not want to use them together. So you might have noticed that from requests, we switched to another library called AIO HTTP. But actually, there are other libraries that do async HTTP requests, like HTTPX. And the logic the issue with Python is that async started coming in at Python 3.5, and then since then it's developed a lot. And as it develops, people have different ideas about how async should be implemented and how you can add them into existing libraries. And so people build their own libraries that are async versions of existing libraries. And when you see between AOHTTP and HTTPX, in the end, with HTTP libraries, what you're trying to do is to work around the HTTP protocol, but do different input-output logic based on your different async backends. So the main idea here is that there's also this movement, or this you can go and read up this page called asyncio, which just means no IO. The idea is that you want to separate out what is just pure HTTP protocol and what is your input-output, and so that you don't have to repeat the work of passing your HTTP and formatting your HTTP across 3 libraries. You have a core HTTP thing, and then you can pair it with different backends. I think that kind of holds for like when we're developing your own projects. If you can separate your IO part from your protocol or from your kind of business logic things, then that allows you to kind of swap out your backends a bit more simply if you can. Yeah, and I think maybe one last point is that if you are reading stuff online, async has moved a lot since Python 3.5. So just kind of check when the resource you are reading was published and what version it's referring to. So recently in my company, I've been updating code from Python 3.6 and 3.7 to 3.12 and 3.11, and it's kind of painful to kind of, okay, this is what has changed in asyncio. This is this kind of pattern. We needed this in 3.5, but we don't need it anymore. So you kind of have to, just check out what you're reading and what tutorials you are following. And I think lastly, just to share a bit about how I use this in my workplace. So as mentioned just now, my company optimizes heating and cooling systems in industrial buildings for energy efficiency. So the idea is we will come onto an existing building, and then we will install IoT gateway on site that will communicate with the building management systems. And these building management systems, generally, they will expose a server that speaks on some particular protocols, and then we will kind of speak to them. So we built some software services that will connect to buildings, speak to them, and then fetch this data, push it to the cloud, receive information from the cloud, send some optimization orders. So as you can imagine, there's a lot of like waiting time, waiting for the building to reply, waiting for the cloud to reply. So if everything is synchronous, it's gonna get a bottleneck within a few minutes probably. But because we have async, we can kind of let everything move up and down in a more efficient way. And that is kind of the end of my presentation. I have some other examples in the repo. So if you want to scan the QR code, you can go back and play around with it in your own time. And it's my LinkedIn as well if you want to connect. So in the repository, I have the examples that I showed just now, and also some other examples with the other async backends if you want to try them out. And another example that launches a basic kind of client server on your laptop. Yep. So if anyone has any questions.
Two questions.
Yes.
So I see that your